So let me quickly get into the topic that in the previous lectures we were talking about uh, the network protocols and the what are the different services are used by the network protocols, and then the Ethernet and the IP address, which are used to identify any end devices in the network. And once they configured with the IP addresses, we try to check whether whether the devices in the network are reachable or not by doing certain connectivity, the operations by following the ping command. And then once the device is in the network, every device is having their physical address, we call the MAC address, but they don't know what is the IP address of other devices. They don't know what is the MAC address of other devices. So there the address resolution protocol is used, and then once the addresses are identified by the end devices in the network, then how the communication takes place between two devices. The logical communication that we have seen in the transport layer by following the process-to-process application on devices. And today, we try to discuss some of the network services which are important to configure the devices. So in this, we call this as the network services. So in this network services, if you talk about this, so we try to learn the basic objectives of your network services, like your, which can provide some kind of services to the attackers, to the network devices, and how these services, analysis of your network security threats that discovered some kind of your malicious activities by your attackers, that we will do in this session. So can you please address any of the network services which we discussed so far? Not in detail, but we addressed a few of the network services.
Address resolution protocol.
Mm-hmm. Yeah. Any other? Yeah, so few of the services which basically known as your network services. One is, as we know that if any device enter into the network, suppose a computer one, when it entered into a private network or public network, it requires a IP address. So that IP address either can be assigned to this computer either manually or dynamically. So this IP address means IP address belongs to which network? It is the network layer service it is. So another one is, once the IP address is assigned, for a human being it is difficult to remember the IP address of every device in the network. So for that, these network addresses or IP addresses further simplified in terms of human understandable, the language we call the domain name services. That is also belongs to your network layer or network service. So then once you know how to map this DNS with your network IP addresses, it may be IPv4 to your DNS or DNS to your IPv4. It requires a special type of service we call the network address translation. Network address translation. Okay. So then once this network address translation is functioned, then you are able to transfer the file from one device to another device. For that, it required another service we call the the FTP services, file transfer protocol services, or the extended of FTP services will be used. And once this is configured, I mean the network address translation is done, then you can use other network services like your FTP or your email services like this, or you can use the web services to access the web functions. So we call these services as the network services. So that in this module, we are trying to explain the network services of this, how they are enabled to give different functionalities of your network. Okay. So first it comes the DHCP, the Dynamic Host Configuration Protocol. So the Dynamic Host Configuration Protocol for your IPv4, any IP version of your v4 version addresses. So why we call this IPv4 version? The IP address represented with 4 bytes, right? So any device that can be used the private IP address or public IP address. So the first 3 bytes, okay, for your class A, class B, class C, whatever we have seen, if you go through the class C IP addresses, use that the first 4 bytes are your network addresses and the last byte is your host address. So total 4 bytes are used, and we have seen the IP version 4 addresses like 192.168.1.15. So this one is your host address, and this part we called as your network addresses. So then your subnet mask, your gateway IPv4 addresses, or your subnet mask, or your gateways. If you take any of these and the other IPv4 network parameters, so they are these particular services are configured either statically or dynamically. If they are configured dynamically, we call the Dynamic Host Configuration Protocol, which provides the service for assigning the IP addresses dynamically to the devices. So when a host connects to the network, the Dynamic Host Configuration Protocol or the DHCP server, we can say, is connected, and an address is requested by the client to this DHCP server. So DHCP server chooses an address from a configured range of your addresses. We call the pool of your addresses, the pool of IP addresses. That means what? If a private network having suppose configured for 254 devices, suppose, then the IP address can be configured like this: 192.168.0.1 is for your root purpose, and it will be configured from this range to this is for your router, the default gateway router it use. If it is starting with 2 and end with 192.168.0.254, so we call from 2 to 254 IP addresses for your host address, we call that is a pool. So any device that entered into the network, it is not necessary that the first entered device will get 2, second entered device will get 3, third entered device will get 4, like that. It is not like that. The first entered device may get suppose 13, second entered device may get 224. So from that pool, any IP address can be randomly assigned by your DHCP server to the device which is requested for the IP addresses. So on large network, yeah.
So the last one is the gateway, and the first one is the broadcast?
Pardon?
The first one is the broadcast, and the last one is the gateway?
getting. If it is starts with 1 means it is your gateway, and if it is this address is end with 255 means it is broadcast. So all the intermediate numbers, they are used to identify the individual devices. So this DHCP can allocate in this scenario, if you see, so there are multiple networks. The corporate networks are, they may have the different branches, but there will be one server we call the Internet Service Provider DHCP server. Upon request by any of these devices, that goes to this, and from whatever pool is there, from that pool, the IP address will be dynamically assigned to this when these devices become active. If these devices become the deactive, then that IP address which is assigned to this device will become idle or release and will be used for any other devices. So this DHCP can allocate the IP address for a configurable period of time only. So we called a lease period, and the lease period is an important DHCP setting. When the lease period expires or the DHCP server gets a DHCP release request type from any of these devices, so then the address is returned to the DHCP pool for reuse by any other the devices. So as you can see in this the diagram, it clearly shows that the various types of devices can be the DHCP servers in this. What are those? You are finding the router DHCP servers. That means the router can assign the IP addresses dynamically to any of the devices inside the network. Or you can find the local DHCP servers for your private networks. Or you can find the DHCP servers for home or small business networks. Or you can find the ISP DHCP servers. So these are different DHCP servers that you can find. That means what? These DHCP servers in most medium to your large networks is usually a local dedicated PC based server. With the home networks or DHCP server is usually located on the local router which connects the home network to your internet service provider part. So different the DHCP servers that you can find. So many networks use both the DHCP and your static addressing basically. That means if you are having the smaller network, you can assign the IP address statically. If you are having the medium to large networks, in that case it is difficult for any network administrator to assign the IP addresses for every individual host in the network. So this DHCP is used for general purpose host such as the end user devices of any of the clients or DHCP clients. So the static addresses is used for the network devices such as your gateway router, switchers, okay, for the border gateway routers or the switches or any single servers inside the network because they are limited in size. So what are the different operations that you can find in the DHCP server as shown in this figure? If it is a client server type of your DHCP, there is a DHCP client and DHCP server will be there. The server is having the range of IP addresses, the pool of IP addresses. So upon when this DHCP client become the part of the network, the first and foremost thing is when an IP in this DHCP configured device boots up, this client, when it boots up or they connect to the network, the client broadcasts a DHCP discover message to identify any available DHCP servers on that particular network by giving this request. So when this message is broadcasted by your DHCP means it use the IP address of this client. So this IP address, it may be your 192.168.1 dot. The host address is supposed to here. To broadcast this message, it use the DHCP broadcast address, that is 5255, so that it will reach to every device in the network, and that request goes to every device, and we call this the servers also your end devices. So they will also receive this what you call the DHCP discover request. So upon receiving this DHCP request, what you call the message, a DHCP server replies with the DHCP offer message based on that. Yeah, I'm in the same network. I have the IP address pool. Okay, so which offers a lease to the client. This offer message, the offers the lease to the client. So the offer message contains the IPv4 address and the subnet mask. And your subnet mask. So why IPv4 address and subnet mask is there in this the DHCP offer message? Any answer for that? That means you are not following me. The question is, in this DHCP offer, it consists of your IPv4 address and subnet masking. Why? What is the use of these two? Why we use mask, submask?
This would be addressed into the network and host address.
Correct. Submasks are used to identify what is the network address portion and what is the host address portion. Then what about the subnetting then? Okay, I just give the brief about that, and I will just leave it about it to you. Submask, as said, used for your separating or identifying network address and host address. Subnetting is used to scale your network. If you are having only 2-3 devices in the network, you can use only, suppose, maximum 3 devices. So to give the IP address for 3 devices, you require maximum how many bits? For 3 devices. 2 bits is more than enough, right? So in the IP address, you are having 32 bits. Out of 32 bits, you can use 2 bits for your host address purpose. Remaining 30 bits you can use for your network address purpose. So doing this, adding the host address bits to your network address portion is nothing but your subnetting. Okay, I don't want to go in details about that. We already discussed that. I hope you haven't covered that one. So in this DHCP, the offer message, it consists of your IP address and subnetting mask. So it shows that what is the IP address that this DHCP server is having, and in that IP address pool, how many IP addresses are available. Subnetting means whether it can accommodate 5 devices in the network, or 100 devices, or 254 devices. Depends. Range. To identify the range, for that the what you call subnetting is used. So the offer message, as said, it consists of these two, and the IPv4 address of your DNS server, the dynamic host configuration server, and the IP address of the default gateway to which this device is connected. The default gateway, or we call the router to which it is connected. Okay. So the lease offer also includes the duration of this lease, that how many days, how many hours, or how many years, depends upon that. So the client may receive the multiple DHCP messages if there are the more than one DHCP server on the local network. If it is having only one, then only one offer will be there. If it is having some the DHCP server of 2, DHCP server of your 3, then the client can receive the multiple DHCP offers. So then it is the choice to the DHCP client to choose whether to connect with the first server, second server, or third server it is. So therefore, it must choose between them and send a DHCP request back to the particular server to which the client wants to connect. So a client may also choose to request the address that it had previously been allocated by the servers. So assuming that the IPv4 address requested by this client or the offered by the server is still available, then the server return a DHCP acknowledgement packet back to your client. So then upon receiving this acknowledgement by this client, the lease has been finalized between your DHCP client and your DHCP server. So if the offer is no longer valid, suppose, then the selected server responds with the DHCP negative acknowledgement message, and if the negative acknowledgement message is that is given to your client, then if this DHCP negative acknowledgement message is returned, then the selection process must begin again with the new DHCP server discovery process again. So this DHCP server ensures that all IP addresses are unique for every DHCP client in the network, and they must be unique. So most internet service providers, they use the DHCP to allocate address to their customers, and the same procedure that happens to with the IPv6 process also. So this is the way of your DHCP operation. So it will be initiated by the client and then responded by your server. So it is a client-server operation, we used to say. So in DHCP, the message format, what will be there in the DHCP message, in the request as well as in the DHCP offer message for leasing purpose. So DHCP IPv4 messages, the format is used to allocate this DHCP v4 transactions. So this DHCP version 4, why we are using version 4 here? Why not using other versions? Why we are using the version 4?
We're using IPv4.
Correct. So this DHCP message format is for version 4 of IP version. If it is 6 means that will support to IPv6. So this DHCP version 4 messages are encapsulated with encapsulated within the UDP transport protocol. So why this UDP transport protocol? Why not TCP transport protocol? Why UDP protocol?
Just so we can use the TCP version. And then we can use
In this scenario, when it is assigning the IP addresses, why DHCP servers use the UDP other than your TCP?
You can't establish a connection if it doesn't have an IP address.
Correct. But in assigning the IP addresses, there is no connection between your client and servers. That's why the UDP is used. Because UDP protocol offers the service that there is no need to establish a connection before communication. Right? So this UDP transport protocol is used by the IP, DHCP version 4 messages. So these messages that are sent from your client, as said, because client don't know who all are the servers present in the network, so it can simply do the flooding of those, broadcasting those packets. So for broadcasting purpose, it simply use the UDP transport protocol. So this UDP, this message, the format of your DHCP sent from your client that uses the UDP source port number, the port number, it used the 68 port number will be used in the for configuring the DHCP IP addresses. Then these messages sent from your server side, suppose server is replying that DHCP your offer messages or your lease messages, they use the destination port number as 67 from your server side. Server use 67 port number. This is your request and this one is your reply. So request uses the 68 port number, reply uses the 67 port number using your UDP transport protocol side. So this messages sent to and fro from your source to destination, means client to server and server to your client. So the basic structure of these messages are having total, it will have the operation code first. So this operation code uses the 8 bits. It uses the 8-bit code. That means this operation code specifies the general type of your messages. That is, if the value of this 8 bits, if it indicates suppose 1. So the value of 1 indicates a request message. A value of suppose 2 is there, this operation code 2 is there, is a reply message. So to check whether the DHCP message of your UDP, the datagram protocol, in that if the opcode is 1 means it is request, 2 means it is a reply. Then it also indicates and shows the hardware portion. So this hardware type that identifies the type of your hardware which is used in the network. For example, if it is 1, suppose, the hardware portion, and this field is holding suppose 1, then it indicates that it is an Ethernet. If it is using suppose 15, this field is using suppose 15, then it is a frame relay. So that use other fiber optic hardware part. If it is suppose 20, it is a serial line. Serial line or serial ports are used. And if it is, so these are the same codes used for your address resolution protocol also. 1, 15 and 20. 1 means your Ethernet, 2 means your frame relay, and 20 means it gives you the serial lines. Okay. So as you can find the serial lines, those cables are having the male side and female side ports, right? Like HDMI cables. You are also having the serial port. That is the hardware part. And along with that, it will also give the address length. So this address length specifies the length of your address, because your DHCP message is having the source IP address, means your server IP address, then default gateway IP address, then whatever the limited range of IP address is there, that will also given to your clients to choose which IP address is chosen by the client. And then the number of hops which exist from your client to your server. So this hubs controls the forwarding of your messages. Simply we can say that what is the path length from your source to the destination. If it is set to 0 by a client before transmitting the request. And then the transaction identifier. Transaction identifier. So this is used by your client to match the request with the replies received from your DHCP servers. And then second one is you are having the seconds time. So it identifies the number of seconds elapsed since a client began attempting to get the IP address from your DHCP server. And then the flag bits are used. These flag bits are used by the client that does not know that its IP address, that it's IPv4 address when it sends a request. So only one of the 16 bits is used, which it is the broadcast flag, because it doesn't know. So in the network, suppose it is having the 192.168. Suppose 1.0 is the network, but your client don't have this IP address, then what it do? 0, 0, 0, and last one it sent to 255, so it will go to every other. It use the last bits. So that is your flag bits, and then client IP address, and this IP address is used by your client during the lease renewal when the address of the client is valid and usable. So not during the process of the acquiring an address. So the client puts its own IP address in the field if and only if it has it's have a valid IP address in that. So then you are having the server IP address in that message, whoever provided the IP address to this client, and then the default IP address, default gateway IP address, the border router IP address we can say, then client hardware addresses, same like the which hardware type is used. So in client hardware addresses that specifies the physical layer of that client. So which one? It will have the MAC address of that client. Then you are having the server name, which is used by your server, offer or server, message acknowledgements, and the boot file name is used. So this is optionally used by the client to request a particular type of boot file in a DHCP offer, a DHCP discover message, and finally you are having some DHCP options that holds the DHCP options, including the several parameters required for DHCP operations. So this field is variable in length. So both client and server may use this field for different service operations. So this is the message format of your DHCP. Okay. So in conclusion, what we can say, the DHCP is basically used for configuring the IP addresses to the larger number of devices in the network. If there are limited number of devices in the network, then the network administrator can simply follow the static IP addresses. So static IP addresses means that can cover either to configure any the border router or some switches in that network or the limited number of servers in that network. So once the IP address is assigned to the end devices in the network, if there are more end devices are there in the network, to remember every device IP address is difficult. So the web servers that we so often connect to using names like we may use google.com, suppose, or cisco.com, or the utsa.edu, or any of these kind of servers to connect these. They are actually reached by assigning the IP addresses to those packets, right? They don't use these names. So on the internet, these domain names are much easier to people to remember than the IP addresses of these devices in the network. So by using the IP addresses, like if there are 100 IP addresses, 100 devices, they are using the IP addresses like 192.168.1.15. Another one is using 10.2.5.6. Another one is using, suppose, 172.16.16. Some 2.5. Another one using 72.16.3. Some 7. So remember these IP addresses is difficult. So instead of that, you may give the name which can be remembered by any individuals like google.com, cisco.com, or utsa.edu.com is easy way. So if the Google decides to change the numeric address of the google.com, suppose, then it is transparent to the user because the domain name remains the same. The domain name remains the same, but only the IP address which is assigned to this may be changed from this IP address to like 172.16.15.68 like that. So it is up to the domain name changer only. The clients, those who are there, they can simply use the the google.com only for that. So this domain name systems was developed to provide a reliable means of managing and providing the domain names and their associated IP addresses. So every domain name like your google.com is associated with any public IP address like 1209.15.2. Like that. So if the lease for this IP address is finished, suppose terminated, they may get another IP address like 211.16.5.26. But for this also the domain name remains same, only the number is changed from the previous lease to the next lease one. So that is the advantage of this. So the DNS system that consists of a global hierarchy of your distributed servers, so that we can see in this case. So this DNS resolves the names to your IP addresses basically. So this DNS system, as said, consists of the global the hierarchy of a distributed servers that contains the database of your names to your IP address mapping. So for example, if you have the global database or root level of your domain, in this case, in this server, the root level domain server, it may be sub level as top level as your .net or .edu, .com, .au, or .co, like that. That is the root one. Inside the root, you will have this second level domain names. So that second level domain names you will find or we call the subdomains, like, cisco.com, or from here, we can write that utsa.edu. Root is this, and this one is your subdomain in that, right? So what you call this, from this subdomain hierarchy, you can use other domains also. Suppose if you write that email, from here we are having the edu is root for UTSA, and from UTSA, if you are using for any web server, suppose you can write the www.utsa.edu, that use the web pages. Suppose if you are using the email services, you may write that the email dot your utsa dot your edu. So this is root, second top level and third top level domains are used here, right? So the client computer in this figure, if you see, that sends a request with the domain name. In this case, what is the domain name request they are sending? Suppose www.cisco.com is sent back. That is the request by your client. So what happens here? To get the, this request will be sent to your DNS server to get the IP address for the www.cisco.com in this case, in this example, so that it can address packets to the servers. So the recent analysis of your network security in this case, the network security threats that discovered over 90% of your malicious software that exploits this DNS system to carry out network attack companions. So you might have heard somewhere that it is written here is www.yourcisco.com, and the same domain name can be used www.cisco.com. The only difference is here it is a lowercase letter, here it is a capital case letter. If the client are unaware of this thing, they can easily connect to this server, and the client feels that they connected to the legitimate server only and start sending packets and receiving packets from that server. But actually, this server is not a legitimate server. So that is one threat, or we call the malicious software, which can do this exploitation process. So a cybersecurity analyst should have a thorough understanding of this domain name system and the ways in which the malicious DNS traffic can be detected through protocol analysis and inspections of your DNS name systems. So that is more important, and the inspection of your DNS monitoring information is very important. So this is what the hierarchy, that is what we observed. The DNS consists of hierarchy in the generic top level domains. We call the GTLD, the small g TLD, generic top level domain name, which consists of like your the .com, .edu, .net, okay, and the numerous country level domains such as your like .aru is an example of that, to provide the hierarchy of the countries like .brazil, .spanish, .uk, .usa, .in, like that. So at the next level of your DNS hierarchies are the second level, and there are the separate by the domain name followed by the top level domain name. That is what we observe, cisco.com or utsa.com, and further it is subdomains are found at the next level on DNS hierarchy and represent same division of second level domain. And finally, a fourth level can represent a host to subdomain. Each element of the domain specifies sometimes called the labeling of that one. You know how we are doing the labeling of those things in that domain names. So this the DNS the main domain, the top level domain, subdomain, and the fourth level domains from your top level domain. So further, how the DNS lookup process takes place here. So to understand this DNS, and cybersecurity analyst or network analyst, should be familiar with certain terms that resolver, we called some of the terminologies in this case. One is your resolver type, who can resolve these domain names. So that is your DNS resolvers we call. And the recursion, we call the DNS recursions. And the authority servers, for those we call the top level servers, the authoritative servers, and the recursive servers of those. So we called resolver, recursive, authoritative server, your recursive server are the resolvers, and you find we call the FQDN. So in this you find a fully qualified domain name system. F stands for fully qualified domain name system. So in this fully qualified domain name system is the absolute name of your device with the distributed DNS. And whereas, as we said, this DNS resolvers, what are their functionalities? So this DNS client that sends a DNS message, any client, DNS client sends a DNS, the message like your any DNS query to discover the IP addresses. So to obtain the information about the requested domain namespace, so this recursion, DNS, the recursive one, that can take some actions on this particular message which is received from your client to ask a specific query on behalf of the DNS resolver. So then the authoritative servers that can identify whether it is a belongs to .com or .org or .brazil or .uk. So which domain it is belongs to. That is the recursive resolver part. And for that, it can use the fully qualified domain name servers like, as we see, the www.yourcisco.com. This is we call the fully qualified domain name system queries. So it can use the RR, we call the resource records in the format which is used by your DNS message, that is composed of certain fields like what is the name of your DNS, type, class, TTL. So the various services that will be provided by resource record. And finally, it will have the zone part. What are the different zones are used in that? So it will, this zone is a database that contains information about the domain name spaces stored on the authoritative servers. These are the authoritative servers part. So when attempting to resolve a name to the IP addresses, a user host known in the system as a resolver will first check its local DNS cache. If the mapping is not found there, then a query will be issued to the DNS server or servers that are configured in the network addressing properties for the resolver part. So these servers may be present at enterprise or the internet service provider part. This the top level one. So if the mapping is not found there, then the DNS server will query other high-level DNS server that are authoritative for the top-level domain name servers we call in order to find the mapping. And there are non-recursive queries will be there from these top-level servers. So because of the potential burden on authoritative top-level domain servers, these are the authoritative top-level domain name servers which you find in this diagram. So some DNS servers in the hierarchy maintain the cache of your DNS records that they have resolved for a period of time. So these caching DNS servers can resolve the recursive queries from without forwarding the queries to the higher level servers, so that will reduce certain burdens on these servers. So the process of transferring blocks of your DNS between the servers that you can easily see in this diagram part. So what are the steps involved in this DNS resolution or DNS lookup process? So first, what happens? The server, the user can type the FQDN part, fully domain name system. So for example, in this case, if you see the fully domain name system is www.cisco.com. So then in step 2, what happens? Upon sending this request by your client, okay, the client is giving this fully qualified your domain name through internet to the servers. So upon receiving this request, the DNS query received by this DNS server for a particular client, it will go via the internet process, internet services, and finally it reach to your destination. So in the third step, upon receiving this message by your DNS server that matches the frequently domain name with the IP addresses with its table, the cache which is maintained inside the server, that is FDP, which is associated with what is the IP address assigned to that cisco.com. So this DNS server that matches the FDP with the numeric address of this, and in return, in the fourth step, it is DNS query response is sent back to your client with the IP address for the frequency domain. What is the IP address? Which is associated with domain name. That is 198.133.219.25. So when the IP address is received by your client, then your client can, or your client computer uses this IP address to make request for the server purpose. That is the fifth involved steps for the DNS resolution that involved in DNS resolution. So next time, whenever the packets are generated by your client, it uses the IP address of your DNS server, and that IP address is encapsulated in the IP header field of this packet as a destination IP address. Source IP address is the client IP address will be used. So this is how the DNS servers use their configuration, and how this DNS address is associated with this numeric values or numeric addresses. So in this, the DNS message format to exchange these messages in between from step 1 to your step 5, the DNS uses the port number or the transport layer protocol, that is UDP, to acquire the associated IP address of your domain name system, and it uses the port number, the UDP port number of your 53. So DNS uses this UDP port 53 for DNS queries and your responses. It may be your request, or reply for that, for those requests. So DNS queries originates at a client, as we have seen in the previous slides, and responses are issued from your DNS server. So if a DNS server exceeds, suppose 512 MB, the 512 bytes in the response messages, such that when you use the distributed dynamic names, or we can sometimes we also call that dynamic domain name systems, DDN. In that case, when it exhausts the maximum size of the packet which is responded from your server to your client, in that case it uses because this is exhausted, so in that case your server uses the TCP port numbers. So it used the TCP port 53 is used. First it go with UDP. If that is exhausted, then it go with the TCP ports. So the DNS protocol communication use a single format we called the message. It used the single format we call the messages. So that message is used for recording the or store the types of the messages which are the resource record, which stores the information what are the type of messages that are resolved by these names. So these records contains in the name, address and type of your records. So that we can see how this header field is basically used for that. So you are having the UDP header and DNS fixed header is there, and the question whether it is a request or the response given to that. So all DNS this uses the same message for all type of client queries and server responses. So when a client makes a query, the server's DNS process first looks at its own record to resolve the name of your DNS here. So if it is unable to resolve the name using the stored record in the RR of your DHCP server side, then it contacts other servers to resolve the name. So after match is found and it returned to the original requesting server, the server temporarily stores the numbered address in the event that the same name is requested again. So the DNS client serves on the Windows PC basically, which also stores the previously resolved names in the memory. So for that it used the IP configure command, which we use the configuration purpose. You can use the IP config, or it can use the display DNS simply. DNS command to display all the DNS entries in that. So as we said, it can answer any of the questions. So DNS message having the section of your question, answer, authority and additional information. So this question is the question for the server. So it contains the domain name to be resolved, like whether you are using the www.cisco.com. Then this is a question, it is asking the server to resolve this, whether this domain name is there or not in that. And the answer for that one is the DNS resource record, we also call the RR for this question, for the query that including the resolved IP address that depending on the RR type, resource record type. Then the authority that contains the RR for the domain authority, which maintains the lease for that IP addresses, and having some additional DNS message sections that are basically used to are relevant to query responses only, which consist of your RR that hold the additional information that will make query resolution more efficient in that. So in this DNS system, or the dynamic DNS we have seen here, when the UDP exhausted, it used the dynamic DNS. So what is this dynamic DNS then? The dynamic DNS that requires the registers to accept and distribute the DNS mapping from organizations that wish to register domain name and IP address mappings from different IP address to your different the domain names. So for mapping purpose, it use the dynamic domain name systems are used. So after the initial mapping has been created, a process which can take 24 hours or more sometimes to change to the IP address that is mapped to the domain name can made by contacting the registrar or using an online form to make the changes. So because of the time it takes for this process to occur and the new mapping to be distributed in domain name system, the change can take hours before the new mapping is available to the resolver. But here in dynamic DNS, that allows a user or organization to register the IP addresses with the domain name as in simple DNS only in this. So however, when the IP address of mapping changes, the new mapping can be propagated through the DNS almost instantaneously in this server process. When something is changed in DNS server, so that query will be given. So in this, the figure, if you see this, the dynamic DNS can be used by the threat actors in various ways in this case. So in this, if you see the differences here, this is a server, this is another server. This server is having the maintaining the IP addresses that 202.203.0.113.2 that is mapped with the DNS name or the domain name system as myhost.dnsprovider.com. And this server is using the another IP address for the same domain name system. Okay, myhost DNS-provider.com. The IP address is 203.0.113.11, whereas here it is using the same domain name with the different IP address. So this server is changing the dynamic IP address of this domain name from this address to your level. Network address is same. So then the host from this DDN that provides the change of your IP address from your dynamic domain name system server, that will provide a different IP address for that request. And from here you can see the user use the old mapping only, that http.myhost.dns.provide.com. Upon giving this request to the server send that request to newly assigned one as well as the DNS server, that is DDN service provider. So from this DDS service provider, the client will get the response, the DNS query or your DNS reply from this provider. So how this happens, this provider? Because the name is, the numeric value is updated, that is possible with the help of your dynamic name systems. Okay. So here, when the change is deleted, the DDNS provides a immediate information of the change and mapping between the user's subdomain in the internet IP address. So there is another important part, how to find out which IP address assigned to which domain name. So for that, there are different tools are used. One of the tool is the WHOIS protocol. This WHOIS protocol is basically used, this is an application which is basically used to identify which IP address is associated with the given domain name. So basically, any the network attackers or malicious nodes, they use this protocol to find out what is the IP address assigned to this domain name, and that IP address further used for exploiting that particular server. So I would like to stop this session here, and